All right, hey again, Honors Chemistry. So I wanted to do kind of a part two recap. We didn't spend too much time doing this, but I wanted to go to the back of worksheet one, where you have to actually go from what's known as a word equation to a balanced chemical equation. Some hints that I don't know or I don't think that we read at the bottom. So you're going to get a bunch of words or names of compounds. And remember, I said the names of compounds are going to haunt you in this course. So you're going to get names of compounds and what they're doing. And you're going to have to write the chemicals, the compounds, the element symbols, right? So clues and hints. Products usually follow words like produces, yields, or forms. Watch for our diatomic elements like H2, N2. Other ones are O2, F2, Cl2, Br2, and I2. So we call them hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine gases, which are often gases. Include state subscripts behind each substance. For when we get back from the spring break now, we're going to have to put the states of matter in. So if it's a solid, you put S. If it's a liquid, L. Gas, G. If it's aqueous, you put AQ when the state is given. Remember, air is a mixture of primarily two gases, O2 and N2. Which is most likely to participate in the reaction? Well, it's going to be O2 gas. That's going to react. Remember, I don't know if you all know, but in order for us to have fire, you need oxygen. So oxygen is needed for reactions, to things to happen. And oxygen is what's going to add on to or react with certain elements or compounds. Elemental metals exist as single unbonded atoms. Example for the formula of copper metal, it's just Cu. If it was sodium metal, Na. Iron metal, Fe. And then finally, watch for ionic versus molecular compounds. Use nomenclature rules and your ion chart and periodic table to figure out the formulas for these. You need to go back into our old videos on our Google Classroom, or that you've saved maybe on the Remind, or on my YouTube channel. I have made several videos on how you name and write formulas for compounds. So you need to revisit that if you are shaky with that or have forgotten. So I'm going to do a couple of examples. So let me do number 2. It says iron burns in air to form a black solid, Fe3O4. All right, so iron is the element. If I look on the periodic table and I try and find iron, iron is Fe. So iron, Fe, and it's going to exist as a solid. Typically, metals exist as solid. So iron solid plus air, which we mentioned at the bottom here that air is a mixture of two gases. Primarily, there are many other gases, but they don't do the reaction, of N2 and O2. But it's going to react with the O2 in the air. So if I ever say air, I'm talking about oxygen. So O2, and that's a gas. And it forms a solid, Fe3O4. And that's a solid. Now, I don't know if you remember how to name this. Luckily, they didn't have to do it for this one. But this is going to be a weird type of compound, okay? So, it's not a normal compound, but it would be iron with some Roman numeral 4, oxide. All right, so you could do the reverse crisscross method, or you could figure out the total charges on all of the irons. If I did the reverse crisscross method, I would figure out that the iron was 4. Now this is a weird compound, Fe3O4. That's why they didn't give you the name. It's not a normal compound. Typically iron would be Fe2 plus or Fe3 And in that case, if I were to make iron oxides, it would be FeO or Fe2O3. So this Fe3O4 is a weird one. So anyways, going back to balancing the chemical equation, I could use particle diagrams to do such. So I have Fe and O2, and I have Fe3O4. So let me represent Fe with a red circle, or a red one. I'll represent O2 again as purple, as I've done in my previous videos. And then I'll represent Fe3O4 as my 3 red circles with 4 purple circles. 1, 2, 3, 4. Okay? All right. Now, if I want to balance this chemical equation, I could do like I've been doing before and notice which elements are not in the same amount on both sides. Off the bat right now, I notice that there are 3 irons on the right side and only 1 iron on the left. So I need to add 2 more irons. And then I notice that there are 4 oxygens on the right side, but only 2 on the left. So I have to add 2 more, and oxygen comes already in the form of O2, so I just have to add another O2. And now I could put my coefficients in for my balanced chemical equation. I needed 4 Fe's and 2 O2's to give me 1 Fe3. Sorry, 3 Fe's, my bad. Not counting correctly. 3 Fe's plus 2 O2's to give me 1 Fe3O4. Okay? So this is what I'm going to be asking you to do for part of our work this week, is going from the word equation to a chemical equation, then to balance it. Let's do another one. Hydrogen peroxide, which they already give it to you as H2O2. O2 has a -2 charge, and this is known as peroxide. This is a polyatomic ion, so it would be good to know about peroxide. It's a polyatomic ion, and remember, you have 1 more month. It's April now. You have 1 more month to remember the names of polyatomic ions. So it says hydrogen peroxide easily decomposes into water and oxygen gas. So hydrogen peroxide, we're going to say H2O2. It didn't give us the state, so let's just say it's liquid. You've all experienced hydrogen peroxide and you don't realize it. It's hydrogen peroxide's in that brown bottle in your medicine cabinet that you use for cuts and scrapes. And that's in liquid form. So hydrogen peroxide easily decomposes into water, which is going to be a liquid, and oxygen gas, G, O2. Remember, water is H2O and oxygen gas is O2. And they already gave you hydrogen peroxide as H2O2. Now I have to balance this. So let me use... Purple is for hydrogen, and red's going to be for oxygen. So I'm going to make H2O2 look like this. Sometimes I switch up the colors. I know I used purple for hydrogen before, but it doesn't matter. All right, and now H2O is going to be a red with 2 purples. And then 2 reds. Okay, so upon first inspection, I'm looking and I see that I have 2 oxygens on the left and 3 oxygens on the right. So it looks like I need to add another H2O2, or I need to add more oxygens on the left side. There were 3 oxygens on the right and only 2 on the left. So the side that it has the less amount of, or the one that I have to add to, I have to add it, and I have to add oxygen in the form of H2O2. Remember, I can't just add a single oxygen because it does not exist by itself on the left side. So I add another one of these. Okay, and now I'm looking to see if I could try and balance this. I have 4 oxygens on the left, but 3 on the right. So I need to add 1 more oxygen on the right side. Now I could either add oxygen in the form of water or oxygen in the form of O2 gas oxygen. Which one makes sense? Well, if I need to add 1 more oxygen, if I add O2, I'm adding too many. If I add H2O, I'm only adding 1. Okay, so I have to add H2O. And now, upon inspection, I see that my equation is balanced. I have 4 O's on the left and 1, 2, 3, 4 O's on the right. I have 4 H's on the left and 1, 2, 3, 4 H's on the right. So now I have to use coefficients. Right, the last step is using coefficients. I needed 2 H2O's. I made H2O2's. I made 2 H2O's and only 1 O2. Now you don't have to use 1. 1 is assumed, but I like to put 1 for right now to make sure you know that a 1 O2 is made in this process. All right, I'm going to do one more example, and I'm hoping these examples can help you. So now I'm going to do number 8, which involves some polyatomic ions and naming and such, okay? So I have sodium hydroxide is added to sulfuric acid. The products are water and sodium sulfate. Now this requires a bit of remembering polyatomic ions and For now, you could look up ions or you could look up formulas. But remember, sodium is Na. And since sodium is Na and it's in group 1 elements tend to form positive charges. Don't forget, group 1 tends to form positive 1 charge. Group 2 tends to form positive 2. Group 3 tends to form positive 3. And then I'm going to skip over to group 7. Group 7 forms negative 1. So fluorine usually is -1 charge. Fluoride is F-1. Chlorine is Cl-1. Br -1. Group 6 tends to form -2 charge, so oxygen's always -2, except if it's in peroxides. Sulfur is always -2. And then group 5 typically forms -3 charge. Nitrogen is typically -3. Phosphorus is typically -3. Use that as a guide for your simple ionic or simple binary ionic compounds. Okay, so sodium is going to be +1, and hydroxide is a polyatomic ion. Hydroxide's not an element. It's not found on here. Hydroxide's going to be OH -1. Okay, now if you remember either the crisscross method or the sum of the charges needs to equal 0, Na +1 and OH -1, I only need one of each that the sum of the charges equals 0. I could do the crisscross method, and I know that I need one OH and one Na. So this helps me figure out that sodium hydroxide is NaOH. Okay? Now, again, you have to remember that if I have an ionic compound, typically the sum of the charges wants to equal 0. So +1 and -1 already gives me that. And we're going to say that sodium hydroxide is going to be aqueous. I'm just making this up so you could see that. It's AQ. And I add it to sulfuric acid, which is, it's already given it to you as H2SO4. Now, we have not named acids yet. And we might not do that until the end of the year. But acids are typically aqueous. They need to be aqueous. Acids are aqueous. Okay? And it says the products are water, which we know is H2O, and sodium sulfate. Again, sodium is Na+1, and sulfate is SO4 2-. Sulfate is a polyatomic ion, right? So if I put it next to here, SO4 2-, I need the sum of my charges to equal 0. So I need to figure out how many of sodiums I need and how many sulfates I need that the sum of their charges equals 0. Well, sulfate is -2 and sodium is +1. If I do the crisscross method, I would notice that I need 1 sulfate and 2 sodiums. So, and that works out because 2 sodiums gives me +2 and 1 sulfate gives me -2. So my sodium sulfate is going to look like this. Na2SO4. Okay? Now notice how I'm trying to leave these spaces. This is what you should be doing. I'm leaving spaces so I could put the coefficients in later. So now, this is going to be a bit tough. Now I'm going to try and draw my particle diagram. So sodium is I'm going to use red for sodium. Okay? And then O, I'm going to use black. And there are going to be 4 O's over here. Okay, and I'm going to use H is going to be purple. Okay. S, I'm going to make green. So S, I already said H is going to be purple. So I have this 2 H's over here. And then O, I said it's going to be black. 1, 2, 3, 4. All right. I said S is going to be green. H is going to be purple. And O is going to be black. So O. There. Okay, so now I made my particle diagrams. Okay, so notice what I was doing, and I was kind of saying it out loud. I was trying to keep track of the atoms and what color I was using. So here's my NaOH, here's my H2SO4, I have H2O, and I have Na2SO4. Upon quick inspection, I notice that I have one NaOH on the left side, or I have one Na on the left side and 2 NAs on the right side. So I'm going to add Na to the left side so I can get that same number of atoms of Na on both sides. And the way that I have to add Na is in the form of NaOH. Okay? Alright. Now I want to count and see what's missing. It looks like my next atom off the top of my head that's not in equal amounts, it looks like I have 6 oxygens on the left, but 5 oxygens on the right. I have 5 oxygens on the right, 4, 5. If I want to add one more oxygen, what would make sense? To add a water molecule or an Na2SO4 molecule? Well, water only has 1 oxygen, so I'm going to add one more oxygen in the form of water, and my equation is going to end up being balanced without me realizing it. Okay? Alright, so my equation is now balanced. I have 2 NAs on the left, 2 NAs on the right. I have 1, 2, 3, 4, 5, 6 oxygens on the left, 1, 2, 3, 4, 5, 6 oxygens on the right. I have 1, 2, 3, 4 hydrogens, which are purple on the left, and look at this, 1, 2, 3, 4 hydrogens on the right in purple. Beautiful. I have 1 sulfur on the left, 1 sulfur on the right. This equation is balanced, and now all I have to do is put the coefficients in. I used 2 NaOHs and 1 H2SO4, and I made 2 H2Os and 1 Na2SO4. Okay? So, I'm hoping this video was helpful in going from the word equation to the chemical equation with symbols to then balancing. This is going to be a huge feat for us, but I'm hoping this video was helpful in trying to remind us on how to name, write formulas, and then eventually balance a chemical equation from the word equation. Hopefully you can work as a team. If you have any other questions or concerns, let me know.